Friends, welcome to secondary physics, waves and sound. Today we'd like to learn amplitude and wavelength. So let's start. From waves and sound, first of all, I'd like to discuss amplitude. What is amplitude? The maximum displacement of the particles either above or below from the mean position is called amplitude. Simply remember that amplitude is the maximum height above or below from the mean or equilibrium position. Usually amplitude is denoted by x0. SI unit of amplitude is meter. Now I am going to show you the way of calculating amplitude. Considering these two waves, now I should measure the distance or length of the peak point from the mean position using a ruler or any measuring device. For example, when I measured the length of this peak point from the mean position, suppose it was 0.005 meter. So the amplitude of this wavelength is x is equal to 0.005 meter. Similarly, in this wave, to find this amplitude, we measure the length of this peak point from the mean position. Let's suppose that the length of this peak point from the mean position is 0.1 meter. So the amplitude of this wave is x is equal to 0.1 meter. Thus, we can also state that the amplitude of this wave is smaller than the amplitude of this wave. Now, what is wavelength? Considering the motion of these two waves, we know that transverse waves travel is consecutive as successive crest and trough, while longitudinal waves travel is successive compression and rarefaction. In case of transverse wave, the length of successive crest and trough is called its wavelength, while in case of longitudinal waves, the length of successive compression and rarefaction is called its wavelength. The Greek letter wavelength is denoted by lambda. Its SI unit is meter. We know that this region is crest and this region is trough. So the length of one crest and one trough is called wavelength or lambda. Let's suppose that its wavelength lambda equals to 0.01 meter. We also know that this region is compression and this region is rarefaction. So the length of one compression and one rarefaction is wavelength or lambda. Let's suppose that its wavelength or lambda is equal to 0.002 meter. Thus remember that wavelength is the length of successive crest and trough, and it is the length of successive compression and rarefaction. Let's see the relation between wave speed, frequency and wavelength. In t second, the wave travels lambda distance. So in 1 second, the wave travels lambda by t distance. This is the wave speed, so velocity v equals to lambda by t. Since f equals to 1 by t, that means frequency equals to 1 by time period, so t equals to 1 by f. So if we put on this value t equals to 1 by f in v equals to lambda by t instead of t 1 by f, then it will be v equals to f lambda. So v equals to f lambda is the relation between wave speed, frequency and wavelength.